to make sure we're all on the same page. So if I ask this question, which I did several times, where does sine start? Starts at 0 and goes up. Okay? So if I wanted to mark the beginning, I'd mark it right here, and the end I'd put about right there. So mark the middle, and then the quarters right here and here. And then remember, the period on this is 2 pi, and the amplitude is 1. So I'm going to go up 1 unit and down 1 unit. And if this is 2 pi, this is going to be pi right here. That would be pi halves, and that's going to be 3 pi halves. Okay? So it's going to start right here, start at 0 and go up to 1. So it's going to hit 1 right here, then back down to 0, down to -1, and then back to 0. So it's going to look something like this. And again, we talked about trying to make this look kind of like a nice curve. So kind of flattens off for a second, comes down here, hits this, flattens off for a second, and then comes back here. And we want to put an arrow on each end, and then we'd label each one of the points. So this is going to be 0, 0. This is pi halves, comma 1. This would be pi, comma 0. And again, remember, the nice thing about sine is we've got 3 points that are on that midline, that center line right there. So this point right here is going to have the same y coordinate as these other 2 points right here. And then this one's up here at 1, that one's down there at -1, so I'm just going to kind of use that right there. And there we go. We've labeled the 5 key points. We've made it look nice. We've labeled the amplitude and the period. There's no phase shift. We haven't shifted it left or right. And we don't have a vertical shift. We haven't moved it up or down. Okay? Where does cosine start? Cosine starts at 1 and goes down, right? So on the parent graph. So again, I'll mark this off here. And if I've done a good job eyeballing on that upper one, we'll use the same scale here. So this is going to be 1, and that's going to be -1. Again, the period is 2 pi, and the amplitude on this, same as it was for sine. So we're going to start up here, and then we're going to go down here and hit 0, down here and hit -1, back up to 0, and then back up here to +1. So cosine looks something like this. Again, kind of round that off just a little bit. Comes down here, levels off for just a second, comes up here, and then goes like that. Okay? So that's a pretty decent looking cosine graph. And then we just run through and we label all the points. So this is 0, 1. If the angle is 0 degrees or 0 radians, the cosine value, okay, the value of the adjacent side is going to be 1. And then this would be pi halves, comma 0. This would be pi, comma -1. 3 pi halves, comma 0. And then this would be 2 pi, comma 1. Right back up where we started, ready to repeat the cycle, repeat that period. Okay? Now, I'll be honest with you. Everybody varies in speed and how accurate they are in graphing and making things look nice and stuff. Do those look like they're pretty good graphs? They don't have kind of that angled shape like I talked about. Don't make them look like this. Okay, we don't want that. Okay, but those look pretty good. And that probably ought to take, I would say, less than a minute apiece. If you can't do it that quickly because you're just too neat and fastidious and stuff like that, I guess that's not the end of the world. If it's taking you longer than that because you flat out have to think about, okay, what's in between 0 and pi? What's this x coordinate right here? If you have to spend some time thinking about that, you need a little more practice. Okay? All right, any questions? Okay, let's take a look at this one then. Okay, what does that 3 tell us? That tells us the amplitude, okay? So the amplitude on this one is 3. What about the period? Has the period changed at all? Is there a period change factor here? Okay, period changes are horizontal changes. They happen in the x direction. In order to speed it up to change the period or slow it down to change the period, you've got to multiply the x by something. Was the x multiplied by anything? Nope. So what's the period? Period's going to be 2 pi. Okay? Is there a phase shift? Has this been shifted left or right? It has. Which is it? Okay. Phase shift is left, so I'm going to write minus pi fourths. And then is there a vertical shift? There is. Okay? So I'll write vertical shift. That's going to be +2. We're going to move it up 2. Okay, now, You could just make one graph and move all the points and get it right. For most people, that's a little bit more difficult. It also doesn't really show how these changes are taking place. Okay? What I suggested to you is you ought to make the right shape and then move it where it needs to go. Okay? So I'm going to keep this in mind. This has been vertically stretched. This is going to go up 3 and down 3 from wherever the center line is. Okay? So I need to make sure that when I mark off this vertical axis that I make room for something that's 3 units above and below the center line, and we're going to take it and we're going to slide it up 2. So what's the highest point on this going to be by the time we're done? 5. So I'm going to do this. I'm going to do 1, 2, 3, 4, 5. And I'm going to try and make those look like they're about the same amount. I'm going to come down here, 1, 2, 3. If you want to go down 5, that's okay, but that's really all we'd have to do for this one right here. Okay? And then I'm going to make the right shape. I'm going to use that same scale we had before. So I'm going to go about to right there, and that's going to be 2 pi. And I'm going to eyeball pi halves, and then 3 pi halves. Okay? And I'm going to change colors. I'm going to do this in black. Actually, I'll tell you what. Yeah, I'll do this in black. I'm going to make the right shape. I'm going to make a sine graph that has an amplitude of 3 and a period of 2 pi. So I'm going to graph this. I'm going to graph y equals 3 sine x. Because that's the right shape. And sine starts where? Okay, starts at 0 and then goes up to, in this case it's going to go up to 3, back down to 0, down to -3, and like this. So this is the right shape. Yeah. It is. This is just the right shape. We haven't moved it anywhere. You were sick when we talked about this. Okay. Actually, I think you were half dead when we talked about this. Okay? So the reason it's nice to do this is, if you look at this, aren't every one of the 5 key points on here, aren't those coordinates pretty darn easy to find? Like if I just point to this one right here, that would be 3 pi halves, comma -3, right? Well, what I need to do in order to make the right graph is I need to move this back pi fourths and up 2. So this is the right shape, it's just not in the right place. So I'm going to draw the new center line. Okay? That new center line is going to be up 2 units. So I'm going to do this. I'm just going to draw a big long horizontal line like this. And I really find that most people are able to draw a better graph if you'll draw in that center line. I'm going to take this point and I'm going to move it back pi halves and up 2. Now, if this is pi fourths and up 2. So if this is pi halves right here, that would be negative pi halves. Where would negative pi fourths be? If that's negative pi halves, right here, that would be negative pi fourths. So we're really only moving it back half a tick mark, if you want to think of it that way. So if I go back pi fourths and up 2, that's going to put me right here. If I go back pi fourths, that's half of one of these tick marks, and up 2, that's going to put me right here. Back pi fourths and up 2, that's going to put me right here. Back pi fourths and up 2, that's going to put me right here. Remember, we're at -3 right here, and then I go up 2, so that's going to put me at -1. Back pi fourths and up 2. Now, notice, this is a sine graph, and notice how nice this is. Remember, we should get 3 points that are on that center line, and there they are. I get 1 point that's above the center line, and I get 1 point that's below the center line. So every one of these is on the center line, so they all have a y coordinate of +2. If I was at 0 and backed up pi fourths, where does that put me? So that's going to be negative pi fourths. If I was at pi, that's where this is, and I backed up pi fourths, that's going to be 3 pi fourths. And if I was at 2 pi and I backed up pi fourths, okay, think about the unit circle, so think about all those common angles that we had memorized. 7 pi fourths. This one I was at pi halves, I backed up pi fourths, so that's going to be pi fourths, comma, remember we went up 2 from 3, so that's going to be comma 5. Make that look nice. And then the last one I need to identify is just that one right there. This would be 3 pi halves. If I back up pi fourths, that's going to be 5 pi fourths. So 5 pi fourths, comma -1, okay? And so the correct graph looks like this. Comes up here, hits this point right here, levels off down here, goes like that, put arrows on that. Now, if you wanted to go back through here and you wanted to erase this shape right here, that's why it's nice to do it in dotted fashion and then do this one solid. That's the right graph right there. Okay? Any questions? Hop, we're doing okay? No questions. Okay. Go ahead and flip the page over then. Okay, would you graph that one, please? Should be narrowing in on being done. Maybe look around, see how your pacing is going, and maybe compare your answer with your neighbor's answer. So we have a new amplitude, right? What's the amplitude? Amplitude is 2. Change in period? No change in period, right? So the period's going to be 2 pi. Phase shift? To the right, pi halves. So we're going to do positive pi halves. And then what about a vertical shift? Down 1. We're going to move it down 1. Okay? So again, I'm going to make the right shape in black. I'm going to make a cosine graph that has an amplitude of 2 and a period of 2 pi. So if the period's 2 pi, I'll just mark these. Now I'm just going to write this as 2 pi. And then I'm going to keep in mind, how big are the tick marks that I'm going to make on the vertical axis? Because I need to fit an amplitude of 2, but then I'm going to move it down 1 unit, right? So I really need to make sure that I can fit 3 units below, right? That'll help me figure out what the scale is. And then this is a cosine graph, so it starts at, or in this case, 2, starts at 2, and then goes like this. Okay, now what will happen sometimes, and I noticed this on the quiz, so everybody listen, okay, because I haven't handed it back. You don't know if you made this mistake. There were some times where people started at like 2 units above that center line, and then they forgot, and when they did this one, they made it look like that. Okay? Remember, this is a vertical stretch, so it stretches the same amount vertically upward as it does vertically downward when it's below that center line or below the x-axis. Okay? So this is the right shape. It's just a little taller than the original parent graph. Okay? And then I need to take this and I need to move it forward pi halves and then down 1. So if I go forward pi halves and down 1, well, the nice thing about this is that tick mark right there is pi halves. That's another pi halves, and that's another pi halves. So these tick marks, they actually line up with how far I need to move it. So I need to move this one forward 1 unit and then down 1. So it's going to be right here. But if I'm going to make an accurate graph, what should I do to make sure that it looks right? Let's draw that center line in there, okay? Because again, if people make the mistake of not going above and below the same amount, you can do the same thing here. So let's take this point and move it forward and down. Should be right on the center line. Forward and down. Forward and down. Forward and down. So it's going to look about like this. Okay? So here's what our graph looks like. And if we knew where those graphs were on the original one, then these should be pretty easy to find. Because if this one was 0, 2, if I went forward pi halves, that's going to put me at pi halves, comma, pi halves, comma 1. This one's going to put me at pi, comma, negative 1. Okay, this one also is going to have a y-coordinate of negative 1. Okay, this one's going to be, where are we here? We're at 3 pi halves, and I'll just take advantage of that right there. How far down would we be? It'd be negative 3, because remember, if the center line is negative 1 and I go down 2 units because that's what the amplitude is, that's going to put me at negative 3. This is going to be 2 pi comma negative 1, and then this is going to be, if I slid this forward pi halves, if I go forward pi halves from 2 pi, where does that put me? 5 pi halves. Very good. 5 pi halves, comma 1. Same y-coordinate as we had right there. Okay? Any questions? Okay. So grab your calculator if you've got it. Okay. I'm going to turn the calculator on right now. Now, let's see. Is that going to come on? There we go. Okay. All right, let's check y equals. Okay, I've got nothing in there. Let's put this in there. So let's put in 2 cosine, and then I've got x minus pi divided by 2, close the parentheses. Now, do I need to worry about this at all? Is that going to do what I think it's going to do? Do I need parentheses around the pi halves? It knows the order of operations. It's going to take pi divided by 2. Then it's going to do the subtraction. So you don't need it. If you were worried about it at all, you could do this. You could insert a set of parentheses around the pi halves. Oops. Okay, and make it look like that. And then minus 1. Okay, now this is a trig class and we're using a calculator. Putting a trig problem in there. What should we do? Check the mode. Okay, let's check the mode. We want to do this in radian mode. Okay, so it's set up in radian mode. Okay, and then we want to set up the window. Now there are a couple things that we could do here. Let's make this look like we did right here. Okay, so let's start at 0. And how far do we need to go in order to get to at least that point right there? How far horizontally do I need to go so I get this entire red graph? I hear somebody whispering at 5 pi halves. I need to go at least to there. Well, the cool thing about this is if I come down here and I put in 5 pi divided by 2, I can literally put that number in there. Okay? And when I come down to the next one, it changes that into a decimal, which is fine. What do we want to use for the scale? How often do we have these tick marks? At pi halves. So let's put that in there. Pi divided by 2. Notice how it changes that, and that's that 1.57 that we're familiar with. Okay? Y min and Y max. How far up and how far down should we have this window be? It's got to go at least down to -3. I'm going to do this just so we can see the whole thing. Let me slide this up. Let's start at -4, and just for symmetry's sake, let's go up to +4. And then is putting a tick mark every 1 unit, does that sound pretty good? Okay. So we should see a picture that looks very similar to this red graph right here. Okay. So I'll go ahead and hit graph. How's it look? Looks pretty good. I can even make it look more the same by putting in this horizontal line right there. I can put in the center line. Okay, and maybe you've seen this before. I'm going to change that. I think we can make it a dotted. There we go. If it's dots like that and it's right next to each other, I guess it just looks solid. So that looks pretty good, doesn't it? Okay. Hit the trace button. Let's check this point right here. Let's check 2 pi -1. Now you can over arrow to that point, or if you're in trace mode, let's just type in 2 pi. And if we did this right, when I hit enter, what should the y coordinate turn out to be? Better turn out to be -1. And it looks like it's right where it should be. Okay? All right. Any questions? Sure? Okay. Let's take a look at this guy then. And I'm going to leave you with a couple of, you can do these 2 problems as homework. Hop's going to study these and come back and do well on the quiz, right, Hop? Same with Noah. What? Yeah, if you guys want to come back later today. You've got that other test that you need to take though, right? Okay. So let's look at this for just a second. A couple things are going on here. There's something wrong with this. Okay, and I mentioned that if you see something like this, you have to change this because you can't look at it and tell everything about it. And this looks kind of nasty right now, by the way. Can somebody tell us what's wrong with it? Huh? Yeah, you've got to pull that out. You've got to factor that out. So I'm going to write it this way. There's nothing wrong with the -1/2. So I'm going to write y equals -1/2. And then this is going to be sine. And this has to be factored. So I'm going to take out a pi. And I'm left with x. And then if I take out a pi, what am I left with here? +1/2. Which looks really awful there. And then that would be plus 1. Okay, so what does that negative do? Okay, so I've got a vertical flip going on here. Okay, what's the 1/2 do? Changes the amplitude. So the amplitude now is 1/2. Not negative 1/2, just 1/2. The negative vertically flips the sine curve, and the 1/2 changes the amplitude. Okay, amplitude is always a positive number. Okay, what about the period? What number did we multiply x by? By pi. Pi is 3.14. It's a pretty big number. So multiplying by 3, does that speed up the graph or slow it down? Multiplying by 3 speeds it up. So it cycles faster, right? If it cycles faster, what does that do to the period? Shrinks it down. We've got that kind of reciprocal relationship. Remember, the period is going to be the old period divided by the period change factor. Period change factor is pi, so what's the new period? New period is 2. Okay? Do I have a phase shift? Phase shift is positive or negative? Negative. Negative 1/2. Okay? And then what about a vertical shift? Got a vertical shift of positive 1. We're going to move the graph up 1 unit. So I'm not going to graph the final one, but we are going to graph the right shape. This has a period of 2. So I'm going to do, and I need to keep in mind, I've got an amplitude of 1/2, so I'm going to go up and down 1/2, and then I'm going to slide the whole graph up 1 unit. So I'm going to call this a half, and this negative 1/2. So this would be 1, and that would be 1.5. Everybody good with that? I've got a phase shift of 1/2 and I've got a period of 2. So I'm going to do this. I'm going to mark that as 2 units. I'm going to eyeball 1 unit and eyeball a 1/2 a unit here and another 1/2 a unit here. Okay, now think really carefully on this. I'm not talking about the end result. I'm not talking about the green graph that we're going to do. I'm talking about this right here. I'm talking about y equals negative 1/2 sine of pi x. That's the shape that I'm going to graph, because that's the right shape, and then I'll take care of moving it left and right and up and down. Okay? Where does this start? Starts at 0 and goes down, but only 1/2 a unit from the center line. So it's going to go down to here, back to here, up to here, and to there. Okay, this is the right shape. It's not in the right place though. But are those 5 key points, are they easy to find? And on this one, as ugly as this looked to begin with, is it pretty easy to move around? Aren't these pretty nice units? Pretty nice units. Okay, then you can take that and you can do the phase shift of negative 1/2. Okay, which notice we've already got the right tick mark there. And then we're going to move it up 1 unit to get that final graph. Okay, are there any questions there? Okay, you can finish that one. I want you to look at this one right here. And I want you to figure out phase shift, period, amplitude, vertical shift. Has it been vertically flipped or anything like that? Figure that stuff out like we did before. So I'm going to do this in blue. So is there a vertical flip? What's the amplitude? What's the period? What's the phase shift, if any? And what's the vertical shift? Does it have a vertical flip? Yes, it does. What's the amplitude? Amplitude's 4. Brandon, what's wrong with this? It's not factored. So I'm going to write y equals negative 4 cosine, and then what am I going to pull out? I'm going to pull out 1/4. Okay, and I'm left with x plus pi, and then plus 2. Okay? So can you tell me what the period is? Remember, the new period is the old period divided by the period change factor. What's the period change factor here? 1/4. If you take 2 pi and divide it by 1/4, you flip that over and you end up with 8 pi. 8 pi is the period. This really stretched it out. It normally does a cycle in 2 pi. It takes 8 pi, 4 times as long to make that same shape. Is there a phase shift? Negative pi. And a vertical shift? Up 2. Okay? All right. Please come tomorrow with that all figured out. If you're missing something from chapter 4, especially in 4.5, or you have some questions, come see me today. Other than that, have a great day. Tomorrow we're going to start on 4.6, so be ready to hit something new. And it relies on you being able to understand these types of graphs. Okay? Have a great day. Yeah.